Question 13b. The diagram shows the graph y equals x over x squared plus 1 for all real x. Consider the function f of x equals x over x squared plus 1 for x greater than or equal to 1. The function f of x has an inverse. Do not prove this. Part 1. State the domain and range of inverse f of x. The domain of f of x becomes the range of inverse f of x. Now in this case, the domain of f of x is x greater than or equal to 1. Hence the range of inverse f of x is y is greater than or equal to 1. From the graph, the point 1, half represents the maximum value of f of x, which is y equals half. Now consider the limit as x approaches infinity of x over x squared plus 1. And we get 0. So the x-axis is an asymptote to the graph. So the graph will never reach 0, but it will certainly approach it. So from that, we can deduce that the range of f of x is y is greater than 0 and less than or equal to half. Hence the domain of inverse f of x is x greater than 0 and less than or equal to half. Putting all that together, we get the domain and range of inverse f of x are x greater than 0 and less than or equal to half, and y is greater than or equal to 1. Part 2. Sketch the graph y equals inverse f of x. One way to sketch the graph of y equals inverse f of x is to reflect the graph of y equals f of x in the line y equals x, taking note of the domain and range of inverse f of x that we found in part 1. Here is a sketch of the graph of y equals inverse f of x, and notice that it starts from the point half, 1. Also note that the graph of y equals f of x is asymptotic to the x-axis, hence the graph of y equals inverse f of x is asymptotic to the y-axis. Part 3. Find an expression for inverse f of x. Starting with the original function f of x equals x over x squared plus 1, rewrite the original function replacing the f of x with the variable y. So it becomes y equals x over x squared plus 1. We'll call that equation number 1. To find an expression for inverse f of x, we're going to swap the x and y variables in equation number 1. So where we see the variable x, we're going to replace it with the variable y, and where we see the variable y, we're going to replace it with the variable x. So from equation number 1, we have x equals y over y squared plus 1. And the next step is to make y the subject. So multiplying both sides of the equation by y squared plus 1, we have xy squared plus x equals y. And subtracting y from both sides, we have xy squared minus y plus x equals 0. The next step is to solve the quadratic equation for the variable y. So using the quadratic formula, we get y equals 1 plus or minus the square root of 1 minus 4x squared over 2x. So we're treating the variable x as a constant and as a coefficient, in fact. Notice though that we have two cases. So we need to determine which case is correct by choosing a value for x in the domain and test that y is in fact greater than 1. So I'm going to choose x equals 0.25 since that's inside the domain of inverse f of x. So case 1, 1 minus the square root of 1 minus 4 times 0.25 squared over 2 times 0.25 gives us a value that's approximately 0.27. And note that that's outside the range of inverse f of x. So case 1 is invalid. In testing case 2, 1 plus the square root of 1 minus 4 times 0.25 squared over 2 times 0.25 gives us a value that's around 3.73, which is inside the range of inverse f of x. So therefore, inverse f of x is equal to 1 plus the square root of 1 minus 4x squared over 2x.